education community stories told by agent-based modeling. And we start uh, the simulation, and you can see the process of community building. And typically the story begins with the text of community has been created or teams are formed within organization. Number of diagrams are then added to the community text to assess the resilience and vitality of teams. This is the usual story that is told about online community where end user have created M pages or digital stories. As usual, community are viewed through the lens of time of existence, the number of registered users, the number of objects created by user and messages posted by user. Most of the time, this simple story is available on community homepage or easily obtained upon request. Main point of my talk is that virtual community stories are not about user or digital object, document, photos, or program. These stories are about network structure groups, teams, or other alliances which emerged upon between user and object. And I continue this idea that is, we go from text about communities to the agent-based models. So we go from text to diagrams, and from diagrams we go to the graphs based on the digital footprints. We can establish the relation between participant and social object. And then we go to animation and the history of collaborators' actions turned into the dynamic sociogram. And then from this sociogram we go to the agent-based models, and we select models to help explain us absurd simulated phenomena. So we can the first example that we use is a story about community-led PC, and we start with the text Untitled, and that is the most famous and long-lived Russian educational wiki project created more than 15 years ago. It initially aimed to setting up hypertext educational encyclopedia, where Learn created a common story about the teachers, schools, and cities. In the following years, we increased the capability of this project through extension like GraphViz, Semantic Media Wiki, Scratchblock, and number of other. And we can see all this process on a table or on the page of this site by itself. And for all this year from 2006 for our time, we can see how many users create pages, article, make editing, and upload a file to LetPC site. It is not only one site because it's a very good regional stories, because LetPC promotes the use of wiki technology in Russian education, and that is more than 60 regional educational hubs using wiki technology, and 5 regional educational hubs on this slide. And we can see wiki from Pskov, Irkutsk, Tольятти, Vladimir, and Vladivostok. And for all of them, we have the data and we have the number about user page, article edits, and files. But we try to go deeper and use the sociogram, the wikigram, that help us to understand how users collaborate inside this wiki page. And we use the special software as a wikigram that help us to understand who participate in editing of pages or in a lot of pages that are collected in one category. And the same idea is used for each year map of wiki pages creation at letpc.org, and we see the story in the WasView software, where it is possible to see the graph of all collaborators who participate in this activity. So that is the next step, and from sociogram we go to the simulation. It is the process of dynamic, how user creates a page, how they collaborate and editing, and how they create a new link between each of them. And the next step from simulation is the agent-based models. So we try to use a lot of different models, and one of them is parameters, which collect the virtual chips on a screen and try to collect them into several new substances. And the next one is the flocking model. When birds try to organize without a leader to the several flocks that was organized and moved in the same direction. And the next one is the giant component model, which is very useful for understanding how people organized and try to check and to make a connection with user with a good with a lot of experience to working with them. And the next part I need to talk about it, that this is the process that was an example of letopsy org is not only about the wiki site. We can use the same technology and the same idea from text to diagrams to graph animation and to agent-based models. We can use the same idea in many sites and a huge variety of user-generated content community. For example, it can be a digital library, it can be Globaloria project about creating games with children. It's of course it's Scratch community where students and teacher create their own project and then they can remix it and make a new version of project. And a lot of NetLogo, StarLogo projects, Looking Glass with Alice machine, and CloudWorks, and WebGrid, and for Russia, letopsy, of course, and Moscow Electronic School. What I try to do right now is to show you how the same approach of thinking about community from text to ABM models is used for Moscow Electronic School. So we start with the text and we talk about the library of Moscow Electronic School. That is a system where multiple roles are offered to user, and the user can be teacher, student, parent, and so on. But every one of them can perform any action about digital object. So we start with the text, then we go to diagram, and in diagram we can see how many scripts was created, number of lessons published on the Moscow Electronic School, number of author who created the projects and scripts, and number of authors who publish the scripts. And then from this text and diagram we go to the next slide, and that is symbols on graphs, how we can present this story. So we have an actor, and as usual there is teachers, and object. It can be scenario of lessons, theme, text, and presentation. And we have a different type of activity, what they can do with the lesson scenario. They can create it, view, remix, launch during the lessons, add to favorite, embed it in homework, and of course they can do it in the same time. So we can go from text to diagrams, from our teacher's profile to action, And then we can create the graph of relationships between different teachers. Each of them create their own project and use the scenario of other teachers. So when they use their own or other teacher projects, they create specific links between different group of teachers. So on the next slide, we try to understand how we can filter all of this different activity from the website and create the community of user which create their own project, copy and organize the teams. So at the very beginning we have about 40 millions of action, and then we filtered them, and in the second table we have only actions without user, which we have not full information, and without the action as view, because we think that is not very important for organizing the team. We try to use only action which is used for team collaboration. And for the third table, we filter action for creative teachers. So if they only view, or if they only favorite or used learning scenario from other teacher, it means that they only user but not a creator. And the last table, it's about 3 millions of actions. And on the next step of our filtering procedure, we use the network fraction graphs, and we start with graphs, bipartite graphs of teacher and scenario, and then we go graph only unipartite graph of user. And the main idea that we are filtering the action of user who make a reciprocal action. So if teacher Boris copy scenario of n, so they make like an invitation to work together, and sometime later the teacher Anna can copy the script from teacher Boris, and that is the principle of reciprocal copying. So we have this the next fraction of user reciprocally copying learning scenario, and we can see on the diagrams on these diagrams that we have a giant component where is about 74% of user create and making reciprocal copying. And on the bottom of this image, we can see that not so many teachers are in dyad or in triad groups. So we go from these diagrams, we go to the story of cave players on the bridge. So we can use the R language and TD graph packages to show and for discussion and for understanding how they connected, how they work together. And then we can filtering from this graph, and maybe we can filter a school creator which work in the same school, and we can discuss this group, and we can see how they collaborate inside it. And that is from the point I started, and I can go to the MATLAB presentation again and show the simulation of this reciprocal framework formation. So we can see how on the screen a different group of teachers from the different school, how they collaborate, and each new step and is the new user on system, or maybe it is a new link between users who are in the system but they don't communicate before. So we go to the presentation again, and what is important there is that we can having information about each teacher or each link in this system. It's just clicking on the image of user of all links, and we get information about them. And the next step from simulation is the agent-based modeling. And the main idea that can we grow the same what we can see in simulation, can we make the same phenomena on the screen and the collected data from these models, and can we grow the artificial community of teacher with reproduce the same phenomena that we see in simulation. We use NetLogo language because most part of educational and research community talk on this language, and because we have a lot of libraries where we can find the models that we can use in our agent-based modeling of Moscow Electronic School. And we have used two models. One is the flocking, and we use a behavior space and make an experiment with a vision parameter. So we change it from 1 to 5, and we see that there's not so not very big effect from changing of vision of agent in this system. And the next models is team assembly. It's very useful, and we try to make some changes in these models and use it for modeling of Moscow Electronic School. And what we try to see is the variables p, which is about probability of choosing of incumbent, probability of choosing the person who have a lot of experience in this system, not a newcomer. So we find that the probability of choosing the incumbent, if it is more than 60%, we can reproduce this phenomena of giant component. So that is the first point what we start, but what we try to use in this presentation in our discussion, that we can go from text to diagrams to graphs to simulation and then to agent-based modeling, and on the basis of digital trace of Moscow Electronic School, we can create the graphs and we have simulation, and we can understand the behavior of user in Moscow Electronic School or on the basis of agent-based models. So we go back to the NetLogo presentation, and I hope it is not it can be continued and we can enjoy it after my presentation. But I think that the last slide and the last idea that I tried to present you right now. Thank you very much, and I will be glad to answer your question.